Welcome to Sparx Science for Sleep, where the wonders of the universe wrap around you like a soft blanket, guiding you into a peaceful night. I'm so glad you're here, maybe curled up in bed, the world outside fading into a quiet hum. Tonight, we're embarking on a gentle journey, one that explores a question as old as the stars themselves. What if we, humans, were not the first to call this planet home? What if, long before our cities and stories, another civilization thrived, their secrets now buried beneath layers of time? This is the heart of the Silurian Hypothesis, a beautiful idea that invites us to wonder about Earth's hidden past. So, take a deep breath, let your shoulders relax, and imagine yourself lying beneath a vast, twinkling sky, each star a whisper of possibility. If you'd like, drop a comment to let me know where you're listening from and what time it is in your corner of the night. Perhaps you're in a bustling city or a quiet village, the clock ticking softly as the world slows down. Picture the Earth as an ancient book, its pages written in stone and sediment, holding stories we may never fully read. The Silurian Hypothesis, dreamed up by curious scientists, asks us to imagine a world where intelligent beings walked millions of years before us. Not humans, but something else, perhaps just as clever, building, creating, maybe even gazing at the same stars you see now. Isn't that a comforting thought? That we might be part of a much larger tale, one that stretches back through eons. As you settle deeper into your pillow, let your mind drift, like a leaf on a gentle stream, carried by the flow of time. The Earth is patient, its secrets tucked away in rocks and rivers, waiting for someone to ask the right question. Tonight, you don't need to solve these mysteries. You only need to listen, to let the ideas wrap around you like a warm breeze. Hush now, and feel your breath slow. Each inhale a quiet wave, each exhale a release of the day's worries. Science, at its heart, is a story of curiosity, a way to explore the world without leaving the comfort of your bed. The Silurian Hypothesis isn't just about ancient civilizations. It's about the magic of wondering what might have been. Imagine a time so distant that entire mountains have risen and fallen since then. Oceans have shifted, and the Earth has remade itself countless times. Yet, somewhere in its vast memory, there could be traces of others who lived, loved, and dreamed. As you close your eyes, picture yourself floating above the planet, seeing its ancient landscapes unfold like a dream. The deserts, the forests, the seas, they all hold whispers of the past, waiting to share their tales with you. Let your thoughts soften, like clouds drifting across a moonlit sky. The beauty of this journey is that it asks for nothing but your presence. You don't need to understand every detail, only to feel the wonder of it all. Scientists like Adam Frank and Gavin Schmidt, who gave us the Silurian Hypothesis, looked at the Earth and saw a puzzle. They wondered if nature could hide the traces of a civilization so completely that we'd never know it was there. It's a bit like searching for a lost letter in a library of endless shelves, each one filled with stories too faint to read. But that search, that quiet curiosity, is what makes science so special. It's a gentle invitation to dream, to imagine, to rest in the unknown. As you sink deeper into this moment, let the weight of the day slip away, like sand through your fingers. Now, imagine you're standing on a quiet shore, the waves lapping softly at your feet, each one carrying a piece of the Earth's ancient story. The Silurian Hypothesis asks us to think about time in a new way, not just years or centuries, but millions of years, stretching back to when the world was a stranger to us. What if, in that distant past, beings built cities of stone or light, their lives as real as yours, their dreams as vivid? As you breathe slowly, feel the rhythm of the Earth itself, steady and eternal. This journey isn't about finding answers tonight. It's about letting your mind wander, free and unhurried, through the vastness of possibility. If you feel sleep tugging at you, let it come, like a friend guiding you to rest. The night is yours, a canvas of calm where science and dreams meet. The Silurian Hypothesis is like a lullaby, sung by the Earth, reminding us that we are part of something much bigger. As you listen, let your body relax, your mind soften, and your heart open to the beauty of the unknown. Picture yourself drifting through time, carried by the gentle current of curiosity. The stars above are watching, their light a reminder that the universe is full of stories, some told, some waiting to be found. And as we begin this journey together, know that you're safe here, wrapped in the quiet wonder of the night. So, let's take one more deep breath and let your thoughts float toward the first chapter of our story, where the Earth's ancient rocks hold secrets waiting to be whispered. As we drift from the quiet shores of imagination, where the Earth whispered its ancient tales, let's now wander deeper into the heart of the planet itself, where rocks hold secrets older than the stars we see tonight. Take a slow, gentle breath and let your mind settle like dust falling softly after a long day. We're here with Sparx Science for Sleep, exploring the Silurian Hypothesis, a question that dances through time. What if others came before us, leaving their mark in the very stones beneath our feet? Tonight, we'll uncover how the Earth's layers, like pages in a forgotten book, might hold clues to civilizations lost to the ages. Let's begin this journey, soft and unhurried, as we sink into the story of the rocks. The Earth is a storyteller, its voice carved in layers of stone, each one a chapter stretching back millions of years. Geologists, like patient readers, study these layers, called strata, to understand the planet's long history. Imagine a cliff face, its bands of color stacked like a painter's canvas, each stripe a snapshot of a time when the world was different. Some layers are made of sand, pressed tight by ancient rivers, others are volcanic ash, frozen in time after fiery eruptions. These rocks don't just tell us about floods or mountains, they might hold hints of something more, something intelligent. The Silurian Hypothesis asks us to wonder, could a civilization, advanced and curious like ours, have left traces in these layers, now buried deep? It's a thought that feels like a whisper from the past, inviting us to listen closely. Geology is the science of time, and it begins with the simple idea that the Earth is always changing. Over millions of years, continents drift, oceans rise, and mountains crumble. This constant motion buries the past, layer upon layer, like a quilt sewn by nature. Scientists look at these layers to piece together what happened long ago. They use tools like hammers and brushes, but also their minds, imagining what each rock might say. For example, a layer of dark basalt might tell of a volcanic eruption, while a band of limestone could speak of an ancient sea teeming with life. But what if, hidden in these layers, there's something unexpected, a strange mineral, a pattern that doesn't fit, a chemical trace that feels out of place? These could be the fingerprints of a civilization that walked the Earth long before us. One way scientists read these stories is through radiometric dating, a method as elegant as a clock ticking through eternity. Rocks contain tiny amounts of radioactive elements, like uranium or potassium, which slowly decay over time. By measuring how much of these elements have changed, scientists can tell how old a rock is, sometimes down to a few thousand years, even if it's billions of years old. Picture a zircon crystal, smaller than a grain of sand, trapped in volcanic ash. Its uranium atoms, like a slow-burning candle, have been decaying since the Earth was young. By studying these crystals, geologists can pinpoint when a layer formed, creating a timeline of the planet's past. If a civilization existed millions of years ago, its tools or structures might be buried in these dated layers, waiting for us to find them. Now, let's imagine a layer of rock deep underground that holds something curious. Perhaps it's a thin band of sediment with an unusual amount of iridium, a rare metal more common in meteorites than on Earth's surface. Scientists found such a layer, dating back 66 million years, marking the asteroid impact that ended the dinosaurs. But what if, alongside that iridium, they found something else, say, a trace of a metal alloy that nature doesn't make? It might look like nothing at first, just a shimmer in the stone, but it could suggest something extraordinary, a civilization that worked with metals, shaping them in ways we can barely imagine. The Silurian Hypothesis encourages us to look for these subtle signs, not grand ruins, but whispers of industry, like a faint echo carried across time. Geologists don't just study rocks for their age, they also look at their composition, the ingredients that make them up. Some rocks, like granite, are born from molten magma cooling deep inside the Earth. Others, like shale, form from mud pressed tight over eons. But sometimes, a rock holds something unexpected, a mineral that doesn't belong, like quartz arranged in a pattern too precise to be natural, or a fragment of something that looks smelted, as if touched by fire not born of volcanoes. These anomalies are rare, but they spark questions. Could they be the remnants of tools, machines, or even buildings from a civilization lost to time? The Earth's crust is like a vast archive, its records incomplete, but full of possibility, waiting for curious minds to explore. The challenge is that nature is a master at erasing the past. Over millions of years, wind, water, and shifting plates grind down even the strongest materials. A city of stone, if it stood 50 million years ago, might now be nothing more than dust scattered across a continent. But some clues might survive, preserved in the right conditions. Imagine a desert, dry and still, where ancient sediments lie untouched, or a cave, sealed from the elements, where strange minerals rest, hinting at a purpose we can't yet understand. Geologists search these places, using microscopes and chemical tests to find traces that don't fit the usual story. It's like looking for a single out-of-place word in a book written by the Earth itself. One fascinating tool in this search is stratigraphy, the study of how rock layers are arranged. Each layer is a moment in time, stacked like pages in a diary. Scientists read these layers to understand the order of events. For instance, a layer of volcanic ash might sit above a bed of clay, telling us an eruption happened after a river deposited that clay. But what if, between those layers, they found something odd, a thin seam of material that looks like it was processed, perhaps a residue from some ancient industry? It might be a mix of metals or chemicals that nature rarely combines. Such a discovery would be like finding a sentence in an unknown language, hinting at a story we've never heard. The Silurian Hypothesis pushes scientists to think differently, to look beyond the usual patterns. Most geology focuses on natural processes, earthquakes, floods, the slow dance of continents. But what if some of those patterns were shaped by intelligent hands? Imagine a layer of rock with a sudden spike in carbon, not from a forest fire, but from something like a factory burning long ago. Or a deposit of rare elements, like platinum, concentrated in a way that suggests mining rather than natural settling. These clues are faint, often so subtle they're mistaken for natural quirks. Yet, with careful study, they might reveal a civilization that thrived when the Earth was young. Another piece of the puzzle comes from studying ancient climates, preserved in the rocks. Scientists can look at the chemicals in a layer like oxygen or carbon isotopes to learn about the air and water of the past. Sometimes, they find oddities, like a sudden shift in these isotopes that doesn't match known climate changes. Could such a shift come from a civilization altering the land, perhaps through farming, building, or burning fuels? It's a question that feels like a gentle breeze, stirring the mind without demanding answers. The Earth's rocks are like a memory, holding on to these faint signals, waiting for us to notice them. Geologists also use fossils within rocks to build their timelines. Tiny shells or plant fragments can show what life was like millions of years ago. But what if, alongside these natural fossils, they found something else? A piece of material that looks crafted, perhaps a fragment of something metallic or synthetic, nestled in a layer from a time when no humans walked the Earth. Such a find would be like a single star blinking in an unfamiliar constellation, urging us to look closer. The Silurian Hypothesis asks us to consider this possibility, to imagine that the rocks might hold more than just the story of nature. The Earth's crust is vast, covering millions of square miles, and only a tiny fraction has been explored in detail. Most of what we know comes from places where rocks are exposed cliffs, quarries, or mountain slopes. But deep underground, or beneath the oceans, there could be layers we've never seen, holding secrets we can't yet imagine. Scientists use drills to pull up cores of rock, like straws, sipping the Earth's history. These cores, sometimes miles long, are studied under bright lights, revealing bands of color and texture that tell of ancient worlds. If a civilization left its mark, it might be in one of these cores, a faint trace waiting to be found. Sometimes, the rocks themselves seem to speak in strange ways. In certain places, geologists have found minerals that don't quite fit like crystals formed under conditions that seem too specific, or deposits of metals that look processed rather than natural. For example, a layer with an unusual amount of nickel or chromium might suggest something was worked, shaped, or smelted. These findings are rare and often explained by natural processes, but they plant a seed of wonder, Could they be the last echoes of a civilization that built things we can't yet comprehend? The Silurian Hypothesis invites us to hold that question gently, like a smooth stone in your hand. The process of finding these clues is slow and careful, like reading a book in a language half forgotten. Geologists use tools like mass spectrometry to analyze the chemical makeup of rocks, looking for anything unusual. They might find a spike in a rare element, or a pattern that suggests something was burned or melted in a way nature doesn't do. These tests are precise, able to detect traces as small as a whisper in a storm. Yet, even with these tools, the Earth's history is vast, and much of it is lost. Layers are crushed by tectonic plates, eroded by rivers, or melted by magma, leaving gaps in the story we're trying to read. One of the most intriguing ideas is that a civilization might have left behind what scientists call technosignatures, marks of technology rather than biology. These could be anything from a layer of synthetic material to a concentration of chemicals that only form through industrial processes. For instance, certain plastics or alloys don't occur in nature, so finding their remnants in ancient rocks would be a powerful clue. The Silurian Hypothesis suggests we look for these signs, not just in the rocks we see, but in the ones we've yet to uncover, buried deep or hidden beneath the sea. The Earth's rocks are like a canvas, painted over countless times, each layer hiding the one before. Yet, some layers might hold secrets that change everything we know. Imagine a geologist, peering through a microscope, spotting a grain of something that looks like it was shaped, not grown. It might be nothing, just a trick of nature, but it could also be a hint of something more, a tool, a fragment, a piece of a world we've never known. The beauty of this science is its patience, its willingness to ask questions without demanding answers right away. It's a story that unfolds slowly, like the Earth itself. As we linger on these ancient rocks, their stories settling around us like a soft fog, let's prepare to drift to another corner of the Earth's past. The stones have whispered their tales, but now it's time to listen to something else. The fossils, those delicate imprints of life, or perhaps something more. Take a moment to breathe deeply, letting the weight of the day slip away. The Earth's history is vast, and we're just beginning to explore its wonders. Let's move gently forward, into a world where the fossils themselves might hold clues to civilizations long gone, their secrets sparkling like stars in the stone. As we slip away from the ancient rocks, their whispered tales of time fading like a gentle breeze, we now wander into a new chapter of the Earth's story, one written not in layers of stone but in the delicate imprints of life itself. Welcome back to Sparx Science for Sleep, where the Silurian Hypothesis guides us through the mysteries of a world that might have known other intelligent beings long before us. Take a moment to breathe deeply, letting the calm of the night settle over you like a soft blanket. Tonight, we're diving into the world of fossils, those sparkling fragments of the past that hold the secrets of life, or perhaps something even more extraordinary. Let's explore the science of paleontology, where each fossil is a puzzle piece, waiting to tell us about creatures, or maybe even civilizations, lost to the ages. Fossils are like letters from a forgotten world, etched in stone, preserving moments from millions of years ago. Paleontology, the study of these ancient remains, is the art of reading those letters, piecing together the story of life on Earth. Most fossils we know are the bones, shells, or leaves of creatures that once swam, crawled, or grew under ancient skies. A dinosaur's massive femur, a trilobite's segmented shell, or the delicate imprint of a fern, these are the usual stars of the fossil record, telling us about ecosystems long vanished. But the Silurian Hypothesis asks us to look closer, to wonder if some fossils might hold clues not just to life, but to intelligence. Could there be fossils that don't quite fit, that hint at something crafted rather than grown, something that whispers of a civilization from a time before humans? Imagine a fossil, small and unassuming, tucked away in a slab of ancient rock. Most fossils form when a creature dies and is quickly buried, its hard parts like bones or shells turning to stone over millions of years. Mud, sand, or ash cover the remains, and slowly minerals seep in, replacing organic material with crystal. It's a slow, patient process, like nature writing its memories in stone. But sometimes, paleontologists find something unexpected, a shape that doesn't look like a bone or a shell, but something more precise, more deliberate. Perhaps it's a fragment with sharp, geometric lines, or a structure that looks like it was shaped rather than formed by nature's hand. These oddities are rare, but they spark curiosity, like finding a single unfamiliar note in a familiar song. Paleontologists use careful tools to uncover these fossils, brushes as soft as whispers, picks as precise as a painter's stroke. They work in quarries, cliffs, or deserts, where the Earth's history is laid bare. Each fossil is a clue, telling us what the world was like when it was buried. A layer of limestone might hold the shells of ancient sea creatures, showing us an ocean that covered the land long ago. A bed of shale might cradle the imprint of a fish, its fins spread as if caught mid-swim. But what if, among these natural remains, scientists found something else? A fossilized fragment that looks like a piece of a tool or a structure with patterns too regular to be natural. The Silurian Hypothesis invites us to consider that such finds might not be mistakes, but messages from a civilization we've yet to understand. One of the most intriguing possibilities is the discovery of microfossils, tiny remnants so small they can only be seen under a microscope. These are often the remains of ancient microbes, like bacteria or algae, preserved in rocks billions of years old. Some microfossils, found in places like Australia or Greenland, date back over 3 billion years, showing us that life began almost as soon as the Earth cooled enough to support it. These tiny fossils are usually simple threads, spheres, or layered mats left by microbial colonies. But every so often, scientists find microfossils that puzzle them. Some have shapes that seem too organized, like miniature grids or branching networks, almost as if they were designed. Could these be the traces of something more than biology, perhaps the remnants of a civilization's smallest creations? Consider a microfossil with a structure that looks like a lattice, its lines too straight, too even, to be the work of microbes alone. Scientists have found such oddities in ancient rocks, like the chert formations of Western Australia, where microscopic patterns hint at something beyond natural growth. These structures might be explained by mineral deposits or chemical reactions, but they also raise questions. What if they're the fossilized remains of something artificial, like a tiny piece of machinery or a crafted material? The Silurian Hypothesis encourages paleontologists to look at these anomalies with fresh eyes, to wonder if they might be technosignatures, marks of technology rather than life. It's a thought that feels like a quiet ripple, spreading through the mind without urgency. Fossils aren't just found in rocks. They can also appear in unexpected places, like amber or tar pits. Amber, the golden resin of ancient trees, can trap insects or plants, preserving them in stunning detail. Tar pits, like those in La Brea, California, hold the bones of Ice Age creatures caught in sticky traps. But what if a fossilized object in amber looked like it was shaped, not grown? Imagine a piece of amber holding something that looks like a tiny gear, its edges smooth and precise. Such a find would be extraordinary, suggesting a civilization that worked with materials in ways we can't yet fathom. Paleontologists would study it with microscopes, analyzing its composition to see if it matches anything natural. The Silurian Hypothesis whispers that such discoveries might be waiting, hidden in the Earth's embrace. Another clue comes from fossils that contain unusual materials, like metals or carbon arranged in ways that don't match nature's usual patterns. Sometimes, scientists find fossils with traces of elements that seem out of place, like nickel or chromium, in concentrations that suggest processing rather than natural deposition. These could be the remnants of tools, machines, or even waste from some ancient industry. For example, a fossilized structure with a metallic sheen found in a layer millions of years old might look like it was smelted or forged. Paleontologists use tools like spectroscopy to analyze these materials, checking for signs that they were shaped by intelligent hands. It's a delicate process, like reading a faint inscription on a weathered page. The fossil record is incomplete, like a book with missing chapters. Most things that die don't become fossils. They decay, eaten away by time or microbes. Only hard parts, like bones or shells, have a good chance of surviving, and even then, they need the right conditions: quick burial, no oxygen, stable surroundings. Soft materials, like wood or fabric, rarely make it through millions of years. This makes the Silurian Hypothesis a challenge. because a civilization's creations, its tools, machines, or buildings might have been made of materials that don't fossilize well. A city of metal could rust away, leaving only faint traces. A structure of plastic might dissolve, blending into the sediment. Yet, some clues might endure, preserved by chance in the right layer of rock. Paleontologists also look at the context of fossils, where they're found and what surrounds them. A fossil in a layer with volcanic ash might tell a story of a fiery catastrophe, while one in a riverbed could speak of a gentle burial by flowing water. But what if a fossil is found with others that don't match? Imagine a layer of ancient seabed filled with the shells of tiny creatures, but among them, a single object that looks like a carved fragment, its edges too sharp for nature's hand. Such a find would be like stumbling across a single word in a foreign language, buried in a familiar text. Scientists would study its shape, its chemistry, its age, trying to understand if it was crafted by something intelligent millions of years ago. Sometimes, fossils show marks that seem deliberate, like scratches or grooves that don't look random. In certain rocks, paleontologists have found fossilized shells with lines that seem too precise, almost like engravings. These could be natural, caused by water or pressure, but they also spark questions. Could they be the work of tools, perhaps from a civilization that left its mark on the world? The Silurian Hypothesis asks us to consider this, to look at these marks not just as accidents, but as possible signs of intent. It's a thought that feels like a gentle wave, lapping at the edges of our understanding, inviting us to wonder without rushing to answers. The study of fossils is a slow, careful dance, blending patience with curiosity. Paleontologists use microscopes that can see details smaller than a grain of sand, revealing patterns invisible to the naked eye. They use chemical tests to check for unusual elements, like carbon or sulfur, that might hint at something beyond biology. In some cases, they found fossils with structures that look layered, almost like composites used in modern technology. These could be natural, formed by microbes or minerals, but they also raise the possibility of something more, a civilization that left behind fragments of its work, now locked in stone. The Silurian Hypothesis is like a lantern, casting light on these mysteries, urging us to look closer. Fossils can also tell us about ancient environments, showing how life adapted to a changing world. Some rocks hold the remains of microbial mats, layers of tiny organisms that live together in communities. These mats, called stromatolites, are among the oldest fossils, some over 3 billion years old. They're usually simple, built by microbes that trapped sediment in their slimy layers. But sometimes, scientists find stromatolites with unusual features, like patterns that seem too organized, or chemical traces that don't match known biology. Could these be signs of something more, perhaps a civilization that influenced the environment in ways we can't yet explain? It's a question that feels like a soft melody, playing in the background of our thoughts. The challenge with fossils is distinguishing between what's natural and what's not. Nature is a clever artist, creating shapes that look designed. Crystals can form perfect hexagons, microbial films can mimic circuits, and mineral deposits can look like tools. Paleontologists must be cautious, using tools like electron microscopes to study fossils at the smallest scales. They look for signs that something was made, not grown edges too sharp, patterns too regular, or materials that don't belong. If a fossil shows signs of being worked, like a polished surface or a precise cut, it could be a clue to something extraordinary. The Silurian Hypothesis pushes scientists to keep an open mind, to see these oddities as possible echoes of a lost world. Sometimes, fossils are found in places that surprise us, like deep ocean sediments or ancient caves. These environments can preserve things that would otherwise vanish. A cave, sealed from the elements, might hold a fossilized fragment that looks like it was shaped, not formed. An ocean floor buried under layers of mud might keep a relic safe for millions of years. Paleontologists explore these places, drilling into the earth or diving into the sea, searching for clues that might rewrite history. If a civilization existed long ago, its fossils might be hiding in these untouched corners, waiting for the right moment to be found. The beauty of paleontology is its ability to connect us to the past, to let us hold a piece of a world long gone. Each fossil is a story, a moment frozen in time. The Silurian Hypothesis adds a new layer to that story, asking us to imagine that some fossils might not be from plants or animals, but from something else, something that thought, built, and dreamed. It's a possibility that feels like a quiet glow, warming the mind without demanding answers. As we linger on these fossils, their secrets sparkling like stars in the stone, let's prepare to drift to another part of the Earth's tale. The fossils have shared their mysteries, but now it's time to explore the chemistry of the past, where the elements themselves might hold clues to a civilization we've yet to meet. As we leave behind the sparkling fossils, those delicate imprints of ancient life glowing softly in the stone, we now drift into a quieter realm, where the Earth's secrets are written not in shapes, but in the invisible dance of atoms. Welcome back to Sparx Science for Sleep, where the Silurian Hypothesis weaves a gentle thread through the mysteries of our planet's past. Breathe slowly now, letting the night's calm settle around you like a warm breeze. Tonight, we're exploring the chemistry of the Earth, a world where elements and isotopes sing a subtle song of what might have been. The Silurian Hypothesis asks us to listen closely, to wonder if the chemical traces in ancient rocks could hint at a civilization that thrived millions of years before us. Let's wander into this story, soft and unhurried, as we uncover the hidden notes of the planet's history. Chemistry is the language of the Earth, a quiet conversation between atoms that tells us about the world as it was long ago. Every rock, every grain of sand, holds a chemical story, written in the elements that make it up: carbon, oxygen, iron, and more. Scientists, like careful listeners, study these elements to understand the past, using tools that can detect the faintest whispers of change. The Silurian Hypothesis pushes this idea further, suggesting that a civilization from millions of years ago might have left behind chemical clues, not grand monuments, but subtle shifts in the Earth's composition. These clues could be as small as a single atom out of place, a tiny anomaly that hints at something extraordinary, like a note played slightly off-key in a vast symphony. At the heart of this chemical tale are isotopes, different versions of the same element with slightly different weights. Carbon, for example, has isotopes like carbon-12 and carbon-13, each with a unique number of neutrons. In nature, these isotopes exist in predictable ratios, like a recipe the Earth follows faithfully. But sometimes, scientists find ratios that don't match, as if someone stirred the recipe in an unexpected way. These anomalies might come from natural events, like volcanic eruptions or ocean currents, but the Silurian Hypothesis asks us to consider another possibility. Could they be the fingerprints of a civilization? Perhaps a society that burned fuels, worked metals, or reshaped the land, leaving behind a chemical echo in the rocks. Imagine a layer of ancient sediment, buried deep beneath a desert plain. Scientists drill into the Earth, pulling up a core of rock that's been untouched for millions of years. Inside, they find a spike in carbon isotopes, heavier than expected, suggesting something unusual happened when that layer formed. It might be the result of a forest fire or a massive bloom of ancient algae, but what if it's something else? A civilization that used fire on a grand scale, perhaps, or one that altered the soil with agriculture or industry. The Silurian Hypothesis encourages scientists to look for these oddities, to see them not just as natural quirks, but as possible signs of intelligent activity, like a faint melody carried across time. One way scientists hunt for these clues is through mass spectrometry, a tool as precise as a jeweler's scale. This machine can measure the weight of atoms in a sample, telling us the exact ratio of isotopes. If a rock shows an unusual amount of a rare isotope, like carbon-14 or lead-206, it might suggest something beyond nature's usual work. For instance, lead isotopes can change when metals are smelted, as ancient humans did to make tools or coins. If a civilization millions of years ago worked with metals, their smelters might have left a trace, a slight shift in lead or copper isotopes, preserved in a layer of stone. It's like finding a single out-of-place thread in a vast tapestry, hinting at a pattern we've yet to understand. The Earth's chemistry is shaped by its history, by the slow churn of its crust and the flow of its ancient seas. But a civilization could have changed that chemistry in small, deliberate ways. Imagine a society that mined rare metals like gold or platinum, leaving behind deposits that don't match the natural scatter of elements. Scientists have found such deposits in modern times, linked to human activity, like the gold mines of South Africa or the coal ash from industrial cities. The Silurian hypothesis wonders if similar traces could exist from a much older time, perhaps in a layer of rock from 50 million years ago, holding a chemical signature that suggests mining, smelting, or even manufacturing. Sometimes, the clues are even more subtle, like a change in the balance of nitrogen or sulfur in ancient soils. Nitrogen isotopes, for example, can shift when plants are grown in large fields, as farmers do today, to feed cities. If an ancient civilization practiced agriculture on a massive scale, it might have left a mark in the soil, a slight increase in nitrogen-15, preserved in a layer of clay. Scientists use tools like gas chromatography to detect these changes, separating the elements in a sample to see what's unusual. These tools are so sensitive they can pick up traces as faint as a single drop of rain in a lake, revealing secrets the Earth has held for eons. The challenge is that nature is a master at mimicking these signs. A volcanic eruption can spike carbon isotopes, mimicking the effects of burning fuel. A meteorite impact can scatter rare metals, looking like the residue of a mine. The Silurian hypothesis asks scientists to be careful, to look at the context of these chemical clues. If a layer of rock shows a strange isotope ratio, they check what else is there: fossils, minerals, or other signs that might tell a fuller story. For example, a layer with unusual carbon isotopes might also hold microfossils or traces of ash, suggesting a natural event. But if it contains something else, like a synthetic compound or a metal alloy, it could point to a civilization's touch. Another fascinating clue comes from synthetic materials, things that don't form in nature. Modern humans create plastics, ceramics, and alloys that leave distinct chemical traces. If an ancient civilization made similar materials, their remnants might still linger in the Earth's crust. Imagine a layer of sediment with a trace of something like silica, but arranged in a way that suggests it was melted and shaped, not naturally formed. Scientists have found such anomalies in rare cases, like glassy beads in ancient rocks that look like they were forged in a furnace. These could be natural, formed by lightning or volcanic heat, but the Silurian hypothesis whispers, what if they're not? The study of ancient chemistry also looks at the air trapped in rocks or ice. Tiny bubbles, locked in amber or frozen in glaciers, hold samples of the atmosphere from millions of years ago. Scientists analyze these bubbles to see what the air was like. Was it rich in oxygen, heavy with carbon dioxide, or laced with something unexpected? If a civilization burned fuels or released chemicals, it might have changed the air, leaving a trace in those bubbles. For example, a sudden spike in methane, a gas linked to industrial activity today, could suggest something similar happened long ago. It's like hearing a faint echo of a song, played on an instrument we've never seen. The Earth's oceans also hold chemical secrets. Sediments at the bottom of the sea build up slowly, layer upon layer, like a diary of the planet's past. Scientists dive into these depths, pulling up cores of mud that hold traces of ancient waters. Sometimes, they find chemicals that don't belong, like high levels of heavy metals or unusual organic compounds. These could come from natural sources, like underwater volcanoes, but they might also hint at something more, a civilization that worked the land or sea, leaving behind a chemical footprint. The Silurian hypothesis asks us to consider these possibilities, to see the ocean's mud as a canvas painted with the past. One of the most exciting ideas is that a civilization might have left behind pollutants, much like we do today. Modern industry releases chemicals like chlorofluorocarbons or heavy metals into the environment, and these can linger in soils or sediments. If an ancient civilization did something similar, their pollutants might still be detectable. Scientists look for these in ancient rocks, using tools like X-ray fluorescence to identify elements that shouldn't be there. A layer with an unusual amount of mercury, for instance, might suggest industrial activity, like smelting or chemical processing. It's a clue as small as a grain of sand, but it could change how we see the Earth's history. The Silurian hypothesis also draws on the study of stable isotopes, which don't decay like radioactive ones. Oxygen isotopes, for example, can tell us about ancient climates, whether the world was warm or cold, wet or dry. But they can also hint at human-like activity. If a civilization built dams or redirected rivers, it might have changed the flow of water, altering oxygen isotopes in nearby sediments. Scientists have seen such changes in modern times, linked to human engineering. Finding them in rocks millions of years old would be like discovering a single word in an unknown script, urging us to read on. The beauty of this chemical search is its precision, its ability to find the smallest traces of the past. Scientists use synchrotron radiation, a kind of super bright X-ray, to study the atomic structure of rocks. This can reveal patterns that are invisible to the naked eye, like a layer of carbon arranged in a way that suggests burning or processing. These tools are like lanterns, illuminating the darkest corners of the Earth's memory. If a civilization left behind chemical traces, these methods might find them, even if they're as faint as a whisper in a storm. Sometimes, the clues are found in unexpected places, like meteorites that fell to Earth long ago. These space rocks carry their own chemical stories, but they can also capture traces of the Earth's surface when they land. If a civilization existed when a meteorite struck, its debris might be mixed with strange chemicals, perhaps a trace of something synthetic, caught in the molten rock of an impact crater. Scientists study these meteorites, looking for elements like iridium or osmium in unusual amounts. The Silurian Hypothesis wonders if such finds could point to a civilization's work, preserved by the chaos of a cosmic collision. The challenge with chemical clues is that they're often ambiguous. Nature can create strange patterns, like a sudden spike in sulfur from a volcanic eruption, or a deposit of rare metals from deep-sea vents. Scientists must compare their findings to what we know about natural processes, looking for anything that stands out. If a layer of rock shows a mix of isotopes that matches industrial activity today, like the burning of coal or oil, it could be a sign of something intelligent. The Silurian Hypothesis asks us to keep looking, to see these anomalies as possible notes in a long-lost melody. The Earth's chemistry is a vast, intricate puzzle, with pieces scattered across continents and oceans. Scientists piece it together, layer by layer, using tools that can see what the naked eye cannot. They look for patterns that don't fit, like a sudden change in phosphorus or a trace of a compound that feels out of place. These clues might be the last echoes of a civilization that built, created, and vanished, their story written in the language of atoms. The Silurian Hypothesis is like a quiet invitation, asking us to listen to that language, to hear the Earth's ancient song. As we linger on these chemical traces, their subtle notes fading into the night, let's prepare to drift to another chapter of the Earth's story. The elements have shared their secrets, but now it's time to explore the great upheavals that shaped our planet, catastrophes that might have hidden or preserved the traces of a lost civilization. Take a moment to breathe deeply, letting the calm of this journey settle over you. The Earth's past is vast, and we're only beginning to uncover its wonders. Let's move gently forward, into a world where disasters and time weave a tale of loss and discovery. As we drift from the quiet symphony of the Earth's chemical whispers, where atoms told tales of ancient secrets, we now wander into a realm where the planet itself reshapes its story with mighty forces. Welcome back to Sparx Science for Sleep, where the Silurian Hypothesis guides us through the shadows of time, asking if civilizations before ours left traces now lost to the ages. Take a slow breath, letting the calm of the night settle like a soft veil. Tonight, we explore the great upheavals of Earth catastrophes like asteroid strikes and volcanic eruptions that might have buried or preserved the clues of a forgotten world. The Silurian Hypothesis invites us to see these disasters as both destroyers and keepers of secrets, painting the planet's past in bold, dramatic strokes. Let's step gently into this tale, where time and turmoil weave a story of loss and possibility. The Earth is a restless artist, forever remaking its surface with forces so vast they can erase entire worlds. Asteroid impacts, volcanic eruptions, and shifting continents have shaped the planet for billions of years, each event a brushstroke in its long history. The Silurian Hypothesis asks us to consider how these cataclysms might have hidden the traces of a civilization that thrived millions of years ago. Imagine a bustling society, perhaps with cities of stone or metal, swept away by a single cosmic collision or buried under layers of molten rock. These disasters don't just destroy, they also rewrite the Earth's story, covering its pages with ash, debris, or new landscapes, leaving only faint hints for us to find. One of the most famous catastrophes in Earth's history happened 66 million years ago, when an asteroid the size of a mountain struck the planet. This event, known as the Cretaceous Paleogene extinction, wiped out the dinosaurs and reshaped life forever. The impact left a scar, a massive crater off the coast of what's now Mexico, called Chicxulub. Scientists found this crater by studying layers of rock that hold a thin band of iridium, a metal rare on Earth, but common in asteroids. This layer, like a line drawn across time, marks a moment when the world changed. The Silurian Hypothesis wonders, if a civilization existed then, could its remnants have been buried in that same layer, mixed with the debris of that cosmic crash? Asteroid impacts are like the Earth's reset button, scattering debris, igniting fires, and altering the climate for centuries. When the Chicxulub asteroid hit, it sent shockwaves across the globe, triggering tsunamis and wildfires. Dust and soot blocked the sun, cooling the planet and starving plants of light. If a civilization had built towers or machines, they could have been shattered, burned, or buried under layers of ash and mud. Yet, the same disaster might have preserved their traces, locking them in sediment like a time capsule. Scientists look for such clues in impact layers, searching for anything that doesn't belong, perhaps a fragment of metal or a chemical trace that hints at something crafted, not natural. Volcanic eruptions, too, play a dual role as destroyers and preservers. Imagine a supervolcano, its eruptions so powerful it blankets entire continents in ash. Such events, like the one that formed the Deccan Traps in ancient India, released rivers of lava that hardened into vast fields of basalt. These eruptions can bury everything in their path, forests, rivers, or even cities, but the ash they leave behind can also act like a protective seal, preserving what lies beneath. Scientists have found ancient creatures, like insects or plants, perfectly preserved in volcanic ash. The Silurian Hypothesis asks, could the ash also hold traces of a civilization, perhaps a tool or a structure, locked away in a layer of stone? The Earth's tectonic plates add another layer of complexity. These massive slabs of crust slide slowly across the planet, pushing up mountains, opening oceans, and swallowing land. Over millions of years, entire continents can disappear, their rocks crushed or melted deep within the Earth. If a civilization built its cities on a plate that was later subducted, pulled under another plate, it might be lost forever, turned to magma. But in rare cases, pieces of that past might survive, caught in a fold of rock or pushed up to the surface. Scientists study these tectonic scars, looking for anomalies that don't fit the natural story, like a metal deposit in a layer where it shouldn't be. Earthquakes, too, can reshape the past. A single quake can crack the ground, bury valleys, or shift rivers, hiding what once stood. But they can also expose hidden layers, revealing rocks that haven't seen daylight in eons. In places like fault lines, where the Earth's crust splits, scientists sometimes find unusual materials, minerals, or chemicals that seem out of place. The Silurian Hypothesis suggests that such finds could be clues to a civilization, perhaps a fragment of something built, caught in the chaos of a quake. It's like finding a single page from a lost book, torn but still legible, waiting for someone to read it. Climate shifts caused by these disasters add another challenge. After an asteroid or volcanic eruption, the Earth's atmosphere can change dramatically. Dust and gases can cool the planet, or greenhouse gases can trap heat, altering ecosystems for thousands of years. If a civilization altered the climate through farming, industry, or burning fuels, its effects might have been erased by these larger events. Scientists study ancient climate records, locked in tree rings or ocean sediments, to understand these changes. A sudden spike in carbon dioxide, for instance, might come from a volcano, but it could also hint at a civilization's activity, now lost in the noise of a greater catastrophe. One fascinating place to look for clues is in impact craters, where the Earth's surface was reshaped in an instant. Craters like Chicxulub or the Vredefort in South Africa hold layers of melted rock and shattered minerals, formed by the intense heat and pressure of an asteroid strike. These layers can preserve materials from the moment of impact, like a snapshot frozen in time. If a civilization existed when an asteroid hit, its debris, tools, structures, or even chemicals might be mixed with the crater's remains. Scientists use drills and imaging tools to study these craters, searching for anything that stands out, like a synthetic compound or a piece of worked metal. Volcanic ash layers are another treasure trove. When a supervolcano erupts, it can spread ash across thousands of miles, settling in thin, distinct layers. These layers act like bookmarks in the Earth's history, marking moments when the world was transformed. Scientists have found ash layers that preserve tiny details, like the wings of an insect or the outline of a leaf. The Silurian Hypothesis wonders if such layers could also hold traces of a civilization, perhaps a fragment of something crafted, buried under ash and hardened into stone. Geologists study these layers with microscopes, looking for anything that doesn't belong, like a chemical trace that suggests industry rather than nature. The Earth's oceans, too, are shaped by disasters. Tsunamis triggered by asteroids or earthquakes can sweep across continents, burying landscapes under layers of mud. These events can destroy, but they can also preserve, sealing materials in oxygen-free environments where decay slows down. Scientists dive into these ancient seabeds, pulling up cores of sediment that hold clues to the past. A layer with an unusual mix of metals or organic compounds might suggest a civilization's work, caught in the aftermath of a great wave. The Silurian Hypothesis sees these layers as pages in a vast, submerged book, waiting to be read. Sometimes, disasters create conditions that mimic human activity. A meteorite impact can melt rocks into glassy forms that look like they were forged in a furnace. Volcanic eruptions can concentrate metals in ways that resemble mining. Scientists must be careful, using tools like X-ray diffraction to study the crystal structure of these materials. If a layer contains something that looks smelted, but its chemistry matches no known natural process, it could be a clue to something more. The Silurian Hypothesis encourages this careful scrutiny, asking us to see these anomalies as possible echoes of a lost world. The passage of time itself is a kind of catastrophe, slowly erasing the past. Over millions of years, erosion wears down mountains, rivers carve away valleys, and glaciers scrape the land clean. A civilization's creations, its buildings, tools or machines might be ground to dust or buried so deep they're beyond reach. Yet, in rare cases, the right disaster can preserve instead of destroy. A sudden flood might bury a city in mud, protecting it from decay. A volcanic eruption might encase artifacts in ash, like a natural vault. Scientists look for these preserved moments, using dating methods like argon-argon dating to pinpoint when a layer formed. The Earth's history is punctuated by mass extinctions, moments when life itself was nearly erased. Besides the dinosaur-killing asteroid, there were others, like the Permian-Triassic extinction 250 million years ago, which wiped out 90% of life. These events left distinct layers in the rock record, marked by changes in fossils or chemicals. If a civilization existed during such a time, its traces might be buried in these layers, mixed with the chaos of extinction. Scientists study these boundaries, looking for anything unusual, a spike in metals, a strange mineral, or a chemical pattern that doesn't fit. The Silurian Hypothesis sees these moments as windows into a past we've yet to fully explore. The challenge is that disasters leave messy records. An asteroid impact might scatter debris that looks like a civilization's waste, or a volcanic eruption might mimic the chemical signature of industry. Scientists use multiple lines of evidence to sort this out, combining fossil records, chemical analysis, and dating methods. If a layer shows a sudden change in isotopes, they check for fossils or minerals that might explain it. If it contains something synthetic, they look at nearby layers for context. This careful work is like untangling a knot, each thread a clue to the Earth's story. The Silurian Hypothesis also draws on the study of ancient climates affected by disasters. After a major event, the Earth's atmosphere and oceans can shift, leaving traces in the rock. Scientists analyze these traces, like oxygen isotopes in ancient corals, to understand what happened. A sudden change might come from a natural catastrophe, but it could also hint at a civilization's impact, perhaps a society that burned fuels or altered the land. The hypothesis asks us to consider these possibilities, to see the Earth's upheavals as both erasers and recorders of history. In some cases, disasters can preserve evidence in unexpected ways. A landslide, triggered by an earthquake, might bury a landscape in a single moment, sealing it from decay. Scientists have found such sites, where entire ecosystems are preserved, like a snapshot of a lost world. If a civilization's artifacts were caught in such an event, they might still be there, hidden under layers of earth. The Silurian Hypothesis encourages scientists to look in these places, using tools like ground-penetrating radar to see beneath the surface without disturbing it. The Earth's great disasters are like a double-edged sword, destroying much, but sometimes saving a fragment of the past. They remind us how fleeting even the grandest creations can be, yet how resilient the planet's memory is. A civilization that thrived millions of years ago might have been erased by a single cataclysm, but it might also have left a trace, locked in a layer of ash or mud. As we linger on these moments of upheaval, their stories settling like dust after a storm, let's prepare to drift to another chapter of the Earth's tale. The disasters have shared their secrets, but now it's time to explore the quiet depths of the oceans, where the planet's archives might hold the last echoes of a lost civilization. As we slip away from the tumultuous dance of Earth's ancient disasters, where cataclysms both buried and preserved the past, we now dive into a quieter, deeper realm, where the ocean's embrace holds secrets older than the mountains. Welcome back to Sparx Science for Sleep, where the Silurian Hypothesis carries us through the whispers of a world that might have known civilizations long before ours. Take a gentle breath, letting the stillness of the night wrap around you like a soft tide. Tonight, we explore the treasures hidden beneath the sea, in the sediments and ice that serve as the Earth's ancient archives. The Silurian Hypothesis invites us to see these depths as a library, where every grain of sand or sliver of ice might hold a clue to a forgotten society. Let's drift into this story, calm and unhurried, as we uncover the silent tales of the ocean's depths. The ocean floor is a vast, hidden library, its shelves built from layers of sediment that have settled over millions of years. These layers, formed from mud, sand, and the remains of tiny sea creatures, pile up slowly, like pages in a book written by time. Each layer captures a moment in Earth's history, preserving traces of ancient waters, climates, and life. Scientists dive into these depths, not with fins and masks, but with drills and submersibles, pulling up cores of sediment that stretch back eons. The Silurian Hypothesis asks us to imagine that among these layers, there might be clues to a civilization, a society that perhaps built along ancient shores, or worked the land in ways that left a mark in the sea's embrace. Sediments on the ocean floor are like a diary, each entry written in the language of minerals and molecules. Tiny shells of plankton, bits of coral, or grains of volcanic ash settle in thin bands, telling stories of ancient seas. Scientists study these cores under microscopes, looking for anything unusual, a spike in a rare metal, a trace of a chemical that doesn't belong, or a pattern that seems too deliberate to be natural. The Silurian Hypothesis suggests that a civilization from millions of years ago might have left such traces, perhaps in the form of processed materials or pollutants washed into the sea. It's like finding a single word in an unfamiliar script, tucked between the pages of a vast underwater tome. One of the most intriguing clues scientists seek is the presence of rare elements, like gold or platinum, in concentrations that nature rarely produces. These metals, often scattered thinly across the Earth's crust, can be gathered by mining or industry, leaving distinct deposits. If an ancient civilization extracted these elements, their work might have washed into rivers and eventually settled on the ocean floor. Imagine a sediment core pulled from the deep Pacific, showing a layer with an unusual amount of platinum dated to 50 million years ago. It might be the result of a meteorite impact, but the Silurian Hypothesis wonders if it could be something else, a sign of a society that shaped the Earth in ways we can't yet imagine. The ocean sediments also hold organic compounds, the remnants of life that once thrived in ancient waters. Scientists analyze these compounds, looking for patterns that stand out. For example, certain hydrocarbons, like those found in oil or coal, can form naturally, but they can also be created by burning fuels. If a civilization used fire or industry on a large scale, its byproducts might have flowed into the sea, settling in layers of mud. Researchers use tools like gas chromatography to separate these compounds, checking for anything that feels out of place, like a molecule that suggests manufacturing rather than nature's slow work. It's a search as delicate as reading a faded letter, looking for meaning in the smallest details. Ice cores, too, are part of the Earth's great archive, though they lie far from the ocean's depths. In places like Antarctica or Greenland, layers of ice have built up over hundreds of thousands of years, trapping tiny bubbles of ancient air. These bubbles are like time capsules, holding the breath of the world as it was long ago. Scientists drill deep into the ice, pulling up cores that reveal the composition of the atmosphere, levels of carbon dioxide, methane, or even traces of dust from distant lands. The Silurian Hypothesis asks if these bubbles might hold clues to a civilization, perhaps a spike in methane from burning fuels or a trace of a pollutant that nature wouldn't produce. The beauty of ice cores is their clarity, each layer a snapshot of a moment in time. A core from Antarctica might show a sudden increase in soot, perhaps from a massive wildfire, but it could also suggest something more, a civilization that burned materials, leaving a faint mark in the air. Scientists use mass spectrometry to study these bubbles, measuring the isotopes of gases like oxygen or nitrogen. An unusual ratio, like too much nitrogen-15, might hint at large-scale agriculture or industry, much like we see in modern times. The Silurian Hypothesis sees these ice layers as pages in a frozen book, waiting for us to read their secrets. The ocean floor and ice cores are studied together, their stories complementing each other. Sediments might show a chemical trace, while ice cores reveal what the air was like at the same time. If both show anomalies, say, a spike in heavy metals in the sediment and a matching change in the ice, it strengthens the case for something unusual. Scientists use dating methods, like counting the layers in ice or measuring radioactive isotopes in sediment, to align these records. If a civilization left its mark, it might appear in both, like a story told in two languages, each confirming the other. The challenge is that the ocean and ice are not perfect record keepers. Sediments can be disturbed by underwater currents or earthquakes, mixing layers and blurring the story. Ice can melt or shift, losing its clarity. Scientists must be careful, using multiple lines of evidence to piece together the past. For example, a sediment core with an unusual amount of mercury might be paired with an ice core showing a spike in the same metal, suggesting a widespread event. The Silurian Hypothesis encourages this careful work, asking us to look for patterns that don't fit the natural narrative, like a single note played out of tune in a vast orchestra. Sometimes, the ocean preserves clues in unexpected ways. In deep, oxygen-poor waters, decay slows down, allowing materials to survive for millions of years. Scientists have found ancient wood, bones, or even pollen grains in these sediments, preserved as if sealed in a vault. The Silurian Hypothesis wonders if such conditions could have saved traces of a civilization, perhaps a fragment of a synthetic material or a tool washed into the sea. Researchers use submersibles to explore these depths, their lights cutting through the dark to reveal layers untouched by time. It's like opening a book that's been closed for eons, its pages fragile but full of possibility. The study of ocean sediments often focuses on microfossils, the tiny remains of plankton or other sea creatures. These fossils, smaller than a speck of dust, can tell us about ancient oceans, whether they were warm or cold, teeming with life or barren. But they can also hold surprises. Scientists have found microfossils with unusual chemical signatures, like traces of carbon that don't match known biology. Could these be the remnants of something artificial? Perhaps a byproduct of a civilization's work? The Silurian Hypothesis asks us to consider this, to see these tiny fossils as possible clues to a world we've yet to understand. Ice cores, too, can hold unexpected treasures. In Greenland, scientists have found cores with layers of ash from ancient volcanoes, each one marking a moment when the Earth roared. But what if, among the ash, they found something else, a trace of a chemical like chlorofluorocarbon, used in modern industry but rare in nature? Such a find would be like a single word in a forgotten language, hinting at a civilization that changed the air itself. Researchers use precise tools, like laser ablation, to study these ice layers, checking for anything that stands out, like a pollutant or a metal that doesn't belong. The ocean's depths are vast, covering 70% of the Earth's surface, and much of it remains unexplored. Scientists estimate that we've mapped only a fraction of the seabed, leaving countless layers untouched. Each core pulled from the deep is a glimpse into the past, but it's like reading a single page from a library of millions. The Silurian Hypothesis suggests that somewhere in these depths there might be a layer with a clue, a synthetic compound, a processed metal, or a pattern that suggests intelligent work. It's a search as patient as the ocean itself, waiting for the right moment to reveal its secrets. The study of these archives also involves looking at ancient climate signals. Sediments and ice can show how the Earth's temperature or chemistry changed over time. A sudden shift, like an increase in carbon dioxide, might come from a volcanic eruption, but it could also hint at a civilization's impact, perhaps a society that burned fuels or cleared forests. Scientists use isotope analysis to study these changes, measuring elements like oxygen or sulfur to understand the environment. If a civilization altered the land or sea, its effects might still linger in these records, like a faint echo of a long-lost song. Sometimes, the ocean's sediments hold clues to global events, like mass extinctions or sudden climate shifts. A layer from 66 million years ago, for instance, might show traces of the asteroid that killed the dinosaurs, but it could also hold something else, a chemical or material that doesn't fit. Scientists have found layers with unusual concentrations of rare earth elements, like neodymium or cerium, that might suggest mining or industry. The Silurian Hypothesis sees these as potential signs, urging researchers to look closer, to wonder if they're the last traces of a civilization swept away by time. The beauty of studying the ocean and ice is their ability to preserve the past in ways the land cannot. On land, erosion and weathering erase much of the record, but the deep sea and polar ice are like vaults, locking away the Earth's secrets. Scientists use remotely operated vehicles to explore the ocean floor, their cameras revealing landscapes untouched by light. In the Arctic or Antarctic, they drill through miles of ice, pulling up cores that glint like crystal in the sun. Each sample is a piece of the puzzle, a chance to find something that changes our understanding of the past. The challenge is that these archives are fragile. Ocean currents can mix sediments, blurring the layers. Ice can crack or melt, losing its story. Scientists must work carefully, using tools like sonar to map the seabed or infrared spectroscopy to study ice cores. If a civilization left its mark, it might be in a single layer, a single core, waiting to be found. The Silurian Hypothesis encourages this patience, this willingness to search for the smallest clues, like a single star in a vast sky. As we linger in the quiet depths of the ocean and the frozen embrace of the ice, their stories settling like silt in still water, let's prepare to drift to another chapter of the Earth's tale. The archives have shared their secrets, but now it's time to explore the tools of the future, the ingenious ways scientists are peering into the past to uncover what might have been. Take a moment to breathe deeply, letting the calm of this journey settle over you. The Earth's history is vast, and we're only beginning to uncover its wonders. Let's move gently forward into a world where technology lights the way to a lost civilization's legacy. As we rise from the tranquil depths of the ocean's archives, where sediments and ice hold the Earth's ancient secrets like a library of forgotten tales, we now turn our gaze to the tools that light the way forward, illuminating the shadows of the past. Welcome back to Sparx Science for Sleep, where the Silurian Hypothesis weaves a gentle thread through the mysteries of civilizations that might have walked the Earth millions of years before us. Take a slow breath, letting the quiet of the night settle around you like a soft glow. Tonight, we explore the ingenious technologies that scientists use to hunt for traces of these lost worlds, from radar that sees beneath the ground to satellites that peer across time. The Silurian Hypothesis invites us to see these tools as lanterns, casting light on the possibility of ancient intelligence. Let's wander into this story, calm and unhurried, as we uncover the marvels of modern science. The search for a civilization lost to time is like looking for a single whisper in a storm, but today's scientists wield tools that can hear even the faintest echoes. Ground-penetrating radar is one such marvel, a device that sends radio waves into the Earth, bouncing them off hidden layers to create a map of what lies beneath. Unlike digging, which can disturb fragile clues, this technology sees without touching, revealing buried structures or anomalies in the soil. Imagine a desert plain, its surface barren, but beneath it, a pattern of shapes that don't match nature's usual chaos, perhaps the outline of a foundation or a cluster of objects too precise to be random. The Silurian Hypothesis asks if such patterns could be the remnants of a civilization, hidden for millions of years, waiting for radar to find them. Satellites, orbiting high above, offer another way to see the past. Equipped with cameras and sensors, they capture images of the Earth's surface in stunning detail, revealing features invisible to the naked eye. Some satellites use infrared or multispectral imaging to detect changes in soil or vegetation that might hint at buried structures. In places like Egypt, satellites have uncovered ancient cities hidden under sand, their outlines faint but clear. The Silurian Hypothesis wonders if similar technology could find traces of a much older civilization, perhaps in a remote valley or a coastal plain submerged long ago. These satellites are like eyes in the sky, scanning the Earth for secrets written in the language of light and heat. Another powerful tool is isotopic analysis, a method that examines the chemical fingerprints of rocks or sediments. Scientists use machines like mass spectrometers to measure the ratios of isotopes, different versions of elements like carbon or oxygen that can reveal the Earth's history. A sudden shift in these ratios, like an unexpected spike in carbon-13, might suggest a natural event, but it could also point to something more like industrial activity from a civilization millions of years ago. These tools are so precise, they can detect traces as small as a single atom out of billions, like finding a single note in a vast symphony. The Silurian Hypothesis sees this precision as a way to uncover clues that time has nearly erased. Seismic imaging, borrowed from the study of earthquakes, is another key to the past. By sending sound waves deep into the Earth and measuring how they reflect, scientists can map underground layers, much like a doctor uses ultrasound to see inside a body. In oil exploration, this technology has revealed hidden caverns or faults, but it could also find something unexpected, a buried structure or a deposit of materials that don't belong. Imagine a seismic scan showing a pocket of metal or synthetic material deep beneath a mountain, dating back tens of millions of years. The Silurian Hypothesis asks us to consider if such a find could be a relic of a civilization preserved in the Earth's crust. Drones have become a new ally in this search, flying over remote landscapes to capture images and data. Equipped with cameras, lasers, or even radar, they can map areas too dangerous or inaccessible for humans. In jungles or deserts, drones have found ancient roads, canals, or settlements hidden by time and growth. The Silurian Hypothesis imagines drones exploring places like the ocean floor or polar ice caps, searching for anomalies that might suggest a civilization's touch, a pattern of stones, a trace of metal, or a chemical signature that doesn't fit. These machines are like tireless explorers, gliding silently over the Earth, seeking stories buried in the land. One of the most exciting tools is synchrotron radiation, a kind of super bright X-ray produced by particle accelerators. This technology can peer into the atomic structure of rocks or fossils, revealing details invisible to standard microscopes. Scientists have used it to study ancient bones, finding traces of blood vessels or proteins preserved for millions of years. The Silurian Hypothesis wonders if synchrotron scans could find something else, a material with a structure too organized, too deliberate to be natural. Perhaps a fragment of a tool or a synthetic compound, locked in a rock from a time before humans. It's like shining a lantern into the deepest corners of the Earth's memory, searching for a glimmer of something lost. Laser ablation is another cutting-edge method, allowing scientists to vaporize tiny bits of a sample and analyze its chemistry. This tool can detect elements, or isotopes, in concentrations so small they're almost unimaginable, like a single drop of ink in an ocean. If a civilization left behind traces of its industry, say, a spike in rare metals like palladium or rhodium, laser ablation could find it. Scientists have used this to study meteorites, finding chemical signatures that hint at their origins. The Silurian Hypothesis asks if similar traces in Earth's rocks could point to a civilization, perhaps one that worked metals or created chemicals long before our time. Artificial intelligence is transforming this search, sifting through vast amounts of data to find patterns humans might miss. Machine learning algorithms can analyze satellite images, seismic scans, or chemical data, spotting anomalies that stand out from the natural background. In archaeology, AI has uncovered hidden sites by recognizing subtle shapes in landscapes. The Silurian Hypothesis imagines AI scanning ancient rock layers, looking for signs of a civilization, a cluster of unusual isotopes, a pattern of minerals, or a structure that defies nature's rules. These algorithms are like silent librarians, combing through the Earth's records for a single misplaced page. Deep core drilling is another way to reach the past, pulling up samples from miles beneath the surface. These cores, like long cylinders of stone, capture layers that haven't seen daylight in millions of years. Scientists have drilled into the ocean floor or ancient lake beds, finding sediments that tell of lost worlds. If a civilization left its mark, it might be in one of these cores a trace of something synthetic, like a plastic-like material or a processed metal buried deep. The Silurian Hypothesis sees these drills as keys, unlocking the Earth's deepest secrets, revealing stories that time has hidden. Geophysical surveys, which measure the Earth's magnetic or gravitational fields, offer yet another approach. These surveys can detect changes in the subsurface, like a pocket of dense material or a void that shouldn't be there. In modern archaeology, they've found buried tombs or walls by spotting differences in the soil. The Silurian Hypothesis wonders if such surveys could find something older, a deposit of materials or a structure from a civilization millions of years gone. These tools are like compasses, guiding scientists through the Earth's hidden landscapes, pointing to clues that lie out of sight. The beauty of these technologies is their ability to see what was once invisible. Ground-penetrating radar can reveal a buried shape without breaking the soil. Satellites can map a continent in a single pass. AI can sift through data faster than any human could. Together, they create a picture of the Earth's past that's richer and clearer than ever before. The Silurian Hypothesis relies on this clarity, asking scientists to look for signs that don't fit patterns, materials, or chemical traces that suggest intelligence rather than nature's random hand. One fascinating example is LiDAR, a technology that uses laser pulses to map the Earth's surface in 3 dimensions. In places like the Amazon, LiDAR has pierced through dense jungle to reveal ancient cities, their roads and canals hidden for centuries. The Silurian Hypothesis imagines LiDAR scanning a remote coastline or a submerged plain, finding shapes that hint at a civilization from millions of years ago. Perhaps a grid of lines, too regular to be natural, or a cluster of objects buried under sediment. LiDAR is like a painter's brush, sketching the outlines of a world we've yet to understand. These tools also work together, combining their strengths to build a fuller picture. A satellite might spot a strange pattern in the landscape, prompting a geophysical survey to map the subsurface. A core sample might reveal an unusual chemical, leading to a synchrotron scan to study its structure. AI could then analyze the data, looking for connections across vast datasets. The Silurian Hypothesis thrives on this teamwork, encouraging scientists to use every tool at their disposal to search for clues that might rewrite history. The challenge is that these technologies, powerful as they are, face the vastness of time. A civilization from 50 million years ago would leave traces so faint they're nearly impossible to find. Erosion, tectonic shifts, and chemical changes can erase or alter evidence, making it look natural. A metal tool might rust away, leaving only a faint stain. A synthetic material might break down, blending into the sediment. Scientists must be meticulous, using tools like electron microscopes to study samples at the smallest scales, looking for anything that stands out: a crystal structure, a chemical bond, or a pattern that suggests intent. Sometimes, these tools uncover surprises in unexpected places. In Antarctica, ice core drills have found layers with traces of ancient pollen, revealing forests that grew millions of years ago. In the ocean, sediment cores have revealed spikes in metals that don't match known geology. The Silurian Hypothesis asks if these could be more than natural quirks, perhaps the last remnants of a civilization's work, preserved by chance. Scientists use isotopic dating to pinpoint the age of these samples, ensuring they align with the right moment in Earth's history. The future of this search lies in even newer technologies still being developed. Quantum sensors, for instance, could one day detect tiny changes in the Earth's magnetic field, revealing buried objects with unprecedented precision. Nanotechnology might allow scientists to analyze samples at the molecular level, finding traces of synthetic materials too small for current tools. The Silurian Hypothesis sees these advancements as new chapters in the story, each one bringing us closer to understanding the Earth's hidden past. These tools are not just machines, they're extensions of human curiosity, reaching into the depths of time to ask questions we've only begun to imagine. The Silurian Hypothesis relies on their precision, their ability to find the smallest clues in the vastness of the Earth's history. A single anomaly, a trace of a chemical, a pattern in the soil, a shape beneath the ground could change everything we know. It's a search as patient as the Earth itself, waiting for the right moment to reveal its secrets. As we linger on these tools of the future, their light shining into the corners of the past, let's prepare to drift to another chapter of the Earth's story. The technologies have shared their marvels, but now it's time to look beyond our planet to the stars, where the Silurian Hypothesis meets the search for life among the cosmos. Take a moment to breathe deeply, letting the calm of this journey settle over you. The Earth's history is vast, and we're only beginning to uncover its wonders. Let's move gently forward, into a world where the universe itself might hold clues to civilizations long gone. As we drift from the glowing tools of science, those ingenious lanterns that pierce the Earth's ancient shadows, we now lift our gaze to the stars, where the universe itself might hold echoes of civilizations long gone. Welcome back to Sparx Science for Sleep, where the Silurian Hypothesis expands beyond our planet, weaving a gentle thread through the vast cosmos. Take a slow breath, letting the quiet of the night settle like stardust around you. Tonight, we explore the possibility that intelligent beings from distant worlds might have visited Earth or left traces elsewhere in our solar system, their stories mingling with the Silurian Hypothesis. This idea, tied to the search for extraterrestrial intelligence, invites us to see the universe as a grand museum, its exhibits scattered across planets and stars. Let's wander into this cosmic tale, soft and unhurried, as we uncover the whispers of alien visitors. The Silurian Hypothesis, which asks if a civilization thrived on Earth millions of years ago, finds a companion in the search for extraterrestrial intelligence, known as SETI. This scientific quest looks beyond our planet, seeking signs of life or technology in the stars. But what if those signs are closer than we think? What if beings from another world visited Earth long ago, leaving traces in our rocks, our seas, or even on nearby planets? The idea is like a faint signal from a distant galaxy, sparking curiosity without demanding answers. Scientists in SETI use telescopes and probes to search for these signs, not just in the form of radio waves, but as physical relics, objects, structures, or chemical traces that might hint at an alien presence. Imagine a meteorite fallen to Earth millions of years ago, carrying not just cosmic dust but a fragment of something crafted. Scientists study meteorites to learn about the solar system's history, analyzing their minerals and isotopes. Some meteorites, like those from Mars, contain traces of gases or compounds that don't match Earth's chemistry. The Silurian Hypothesis, paired with SETI, asks if such a meteorite could hold something more: a piece of a tool, a shard of a material too precise to be natural. Researchers use tools like laser spectroscopy to examine these space rocks, looking for patterns that suggest an artificial origin, like a metal alloy or a structure that defies geology's rules. The surfaces of other planets and moons in our solar system offer another place to look. Mars, with its ancient riverbeds and frozen poles, has long been a target for exploration. Rovers like Perseverance roam its surface, collecting samples that might hold signs of past life, or perhaps something more. The Silurian Hypothesis extends to these worlds, wondering if a civilization, alien or Earthborn, left marks on Mars millions of years ago. A strange pattern in the soil, a cluster of minerals that looks worked, or a chemical trace that doesn't fit could be a clue. Scientists use cameras and drills to study these surfaces, searching for anything that stands out, like a single note in a cosmic melody. Jupiter's moon Europa, with its icy crust hiding a vast ocean, is another intriguing possibility. Beneath its frozen surface, liquid water might hold clues to life or technology. If an alien civilization visited our solar system, they might have explored Europa, leaving behind a probe, a tool, or a chemical signature. Scientists plan missions to drill through the ice, using robots to search for organic compounds or unusual materials. The Silurian Hypothesis asks if such a find could link back to Earth, suggesting that a civilization, whether from here or elsewhere, explored our cosmic neighborhood long before humans looked to the stars. Saturn's moon Enceladus adds to the mystery, with its geysers spraying water and particles into space. These plumes, captured by spacecraft like Cassini, contain salts, organic molecules, and even traces of silica that hint at hydrothermal activity. But what if they also hold something unexpected? A synthetic compound, a fragment of a material that doesn't belong? The Silurian Hypothesis, through the lens of SETI, imagines that such a discovery could point to a civilization that visited or lived in our solar system. Scientists analyze these plumes with mass spectrometers, looking for anything that breaks the pattern of natural chemistry, like a whisper from a world we've yet to meet. Beyond our solar system, SETI searches for technosignatures, signs of technology that could indicate an advanced civilization. One famous idea is the Dyson sphere, a theoretical structure built around a star to capture its energy. Such a megastructure would change the star's light, making it dim or flicker in unusual ways. Scientists have observed stars like Tabby's star, which dims unpredictably, sparking speculation about artificial structures. While natural explanations, like dust clouds, are more likely, the Silurian Hypothesis wonders if such a structure could have existed in our galaxy's past, its remnants perhaps influencing Earth or nearby planets. Telescopes like the James Webb scan these stars, seeking patterns that defy nature's rules. Asteroids and comets, drifting through space, might also carry clues. Some asteroids, like those in the asteroid belt between Mars and Jupiter, contain metals or compounds that seem out of place. Scientists study these with probes, like the Psyche mission, which explores a metal-rich asteroid. If a civilization mined or worked these bodies, they might have left traces, a carved surface, a deposit of processed material, or a chemical signature. The Silurian Hypothesis, tied to SETI, asks if such traces could connect to Earth, perhaps carried here by a meteorite or left behind by visitors who explored our system millions of years ago. Cosmic dust, tiny particles floating between stars, offers another avenue. Collected by spacecraft or studied in Earth's atmosphere, this dust can carry complex organic molecules or unusual isotopes. Some particles, found in meteorites, contain amino acids or hydrocarbons that hint at the building blocks of life. The Silurian Hypothesis wonders if they could also hold fragments of technology, perhaps a nanoscale structure, or a chemical that suggests artificial processing. Scientists use electron microscopes to study these particles, looking for anything that stands out, like a single grain of sand that tells a story of a distant world. The search for alien artifacts on Earth itself is a tantalizing possibility. Imagine a rock layer, buried deep, containing a fragment that looks too perfect, too deliberate, to be natural. Scientists have found objects in archaeological sites that puzzle them: odd shapes, unusual materials, or carvings that don't fit known cultures. The Silurian Hypothesis, through SETI's lens, asks if these could be relics of extraterrestrial visitors left behind millions of years ago. Researchers use tools like X-ray fluorescence to analyze these objects, checking their composition for signs of alien origin, like a metal alloy or a synthetic compound that Earth's geology can't explain. The moons of our solar system, like Titan with its methane lakes or Ganymede with its magnetic field, are also places to look. If a civilization explored these worlds, they might have left probes, markers, or chemical traces. Scientists study these moons with telescopes and spacecraft, searching for anomalies, a pattern in the ice, a signal in the atmosphere, or a structure buried beneath the surface. The Silurian Hypothesis imagines that such a find could link back to Earth, suggesting that a civilization, whether from here or beyond, left its mark across the solar system. Its story written in the language of ice and stone. Radio telescopes, like the Allen Telescope Array, play a key role in SETI, listening for signals that might come from intelligent beings. But they also search for faint, ancient emissions, perhaps the last echoes of a civilization's technology. A signal that's too regular, too precise, to be natural could be a clue, even if it's millions of years old. The Silurian Hypothesis asks if such a signal could have reached Earth long ago, its source now silent, but its mark left in our rocks or atmosphere. Scientists analyze these signals with computers, sifting through noise to find patterns that hint at intelligence, like a whisper carried across the stars. Spectroscopy, which studies the light from stars and planets, is another powerful tool. By breaking light into its colors, scientists can learn about the chemistry of distant worlds. An atmosphere with unusual gases, like chlorofluorocarbons or industrial pollutants, could suggest a civilization's presence. On Earth, spectroscopy has revealed traces of ancient climates in rocks and ice. The Silurian Hypothesis wonders if it could also find signs of alien visitors, perhaps a chemical trace in a meteorite or a layer of sediment that doesn't match Earth's natural history. This tool is like a lens, focusing the universe's light to reveal its secrets. The Kuiper Belt, a ring of icy bodies beyond Neptune, is another place to search. These objects, frozen for billions of years, might hold clues to ancient activity. If a civilization explored or mined the belt, they could have left structures or materials behind. Scientists study these bodies with telescopes and probes, looking for anything unusual, a pattern of craters, a chemical signature, or a shape that suggests intent. The Silurian Hypothesis sees this as a cosmic archive, where the relics of a civilization might be preserved, waiting for us to find them. The Oort cloud, a distant sphere of comets surrounding our solar system, offers a similar possibility. These comets, untouched for eons, could carry fragments of a civilization's work. A comet with an unusual composition, say, a trace of a synthetic material, might suggest contact with intelligent beings. Scientists use spectroscopy to study comets as they pass near Earth, checking for anomalies that don't fit. The Silurian Hypothesis imagines that such a find could connect to Earth's past, perhaps a relic from a visitor who left a mark millions of years ago. The challenge is distinguishing between natural and artificial signs. The universe is full of strange phenomena, pulsars that pulse like clocks, stars that dim from dust clouds, or comets with complex chemistry. Scientists must be cautious, using multiple tools to verify their findings. A meteorite with an odd isotope ratio might come from a supernova, not a civilization. A pattern on Mars might be a natural erosion, not a structure. The Silurian Hypothesis, through SETI, encourages this careful scrutiny, asking us to look for clues that stand out, like a single star in a crowded sky. The beauty of this search is its vastness, its ability to connect Earth to the cosmos. The Silurian Hypothesis and SETI together ask us to see our planet as part of a larger story, one that might include visitors from distant worlds. A single find, a fragment, a signal, or a chemical trace could change everything, linking our past to the stars. It's a search as patient as the universe itself, waiting for the right moment to reveal its secrets. As we linger on these cosmic possibilities, their echoes fading like starlight at dawn, let's prepare to drift to another chapter of the Earth's story. The stars have shared their mysteries, but now it's time to reflect on what it all means for us, the humans who wonder about our place in this vast tale. Take a moment to breathe deeply, letting the calm of this journey settle over you. The universe's history is vast, and we're only beginning to uncover its wonders. Let's move gently forward into a world where we ponder our role in the grand story of existence. As we float gently away from the cosmic museum of the stars, where whispers of ancient civilizations might linger in the vastness of space, we now turn inward to a quieter, more reflective corner of our journey. Welcome back to Sparx Science for Sleep, where the Silurian Hypothesis has carried us through layers of rock, fossils, and the distant reaches of the cosmos, asking if others walked this Earth or visited our skies long before us. Take a slow breath, letting the stillness of the night settle like a soft veil over your thoughts. Tonight, we pause to ponder a profound question. If civilizations rose and fell before humanity, what does that mean for us? The Silurian Hypothesis invites us to reflect on our place in this grand story, to consider the fragility, humility, and lessons of existence. Let's drift into this contemplative tale, calm and unhurried, as we explore the meaning of being human in a universe that may have known others. The Silurian Hypothesis challenges a story we've long told ourselves, that humans are the first and only intelligent beings to shape the Earth, to build cities, to dream of the stars. For centuries, We've seen our history as a steady climb, from simple tribes to towering skyscrapers, a singular arc of progress. But what if we're not the first chapter in this book? What if others came before, their societies as vibrant as ours, only to vanish beneath the weight of time? This idea, like a gentle ripple across a still pond, asks us to rethink our uniqueness. It suggests that intelligence, like life itself, might be a recurring theme in the Earth's long symphony, rising and falling in cycles we're only beginning to understand. If a civilization existed millions of years ago, its disappearance raises sobering questions. What caused it to fade? Did it crumble under its own weight, perhaps through conflict or overuse of resources? Or was it swept away by a natural catastrophe, like an asteroid or a volcanic eruption? These questions mirror our own concerns today: climate change, technological risks, the delicate balance of our world. The Silurian Hypothesis offers a lens through which to see our own fragility, reminding us that even the grandest societies are fleeting in the face of time. A civilization that built wonders might now be nothing more than a faint trace in a rock layer, a lesson in how quickly the Earth can reclaim what we create. The idea of earlier civilizations also invites humility. For so long, humans have placed themselves at the center of the universe, believing our languages, tools, and dreams set us apart. Ancient philosophies and religions often cast us as the chosen, the pinnacle of creation. But what if intelligence has bloomed before, in forms we can't imagine? Perhaps beings with minds as sharp as ours, or sharper, walked this planet when it was young, their thoughts and creations lost to the ages. This possibility softens our sense of supremacy, suggesting we're but one note in a vast melody, part of a larger story that stretches beyond our understanding. This reflection also touches on the myths and stories of ancient cultures. Many civilizations, from the Sumerians to the Greeks, told tales of lost worlds, Atlantis, Lemuria, or realms of gods and giants. Could these be echoes of something real, distant memories of a time when others thrived? The Silurian Hypothesis asks us to consider these stories not just as myths, but as possible fragments of a deeper truth. A tale of a city swallowed by the sea might hold a kernel of history, a civilization buried by a catastrophe we've yet to uncover. It's like finding a single page from a lost manuscript, hinting at a story we've forgotten. The fragility of civilizations is a key theme in this reflection. If others rose and fell, what does that say about our own future? Today, we face challenges that echo the past changes in climate, the strain of resources, the risks of technology. A civilization millions of years ago might have faced similar struggles, perhaps building machines that altered their world or farming lands until they could give no more. The Silurian Hypothesis suggests that their fate could be a mirror, reflecting the choices we make now. It's a quiet reminder that progress is not guaranteed, that even the most advanced societies can vanish, leaving only whispers in the Earth's archives. This idea also reshapes our view of progress itself. We often measure success by growth, bigger cities, faster machines, more power. But what if true progress lies in balance, in living with the Earth rather than reshaping it? A civilization that thrived millions of years ago might have found harmony with its world, leaving fewer traces because it tread lightly. Or perhaps it pushed too far, altering the climate or land until it could no longer sustain itself. The Silurian Hypothesis asks us to consider what legacy we want to leave, whether our story will be one of endurance or a fleeting mark in the stone. The philosophical weight of this idea extends to our sense of connection. If others lived before us, they were part of the same Earth, breathing its air, walking its lands. Their dreams, though different, were born under the same sky. This shared history, even if hypothetical, ties us to the past in a profound way. It suggests that intelligence is not unique to us, but a gift that the Earth may offer again and again, like a river that flows through time. The Silurian Hypothesis invites us to see ourselves as part of this cycle, not the end of it, fostering a sense of kinship with those who might have come before. This reflection also touches on the limits of our knowledge. The Earth is billions of years old, yet our history spans only a fraction of that time. The Silurian Hypothesis reminds us that much of the past is hidden, erased by the slow grind of geology or the chaos of catastrophe. If a civilization existed 50 million years ago, its cities might be dust, its tools rusted away, its stories lost. Yet, the The possibility that they existed at all changes how we see ourselves. It's like standing at the edge of a vast ocean, knowing its depths hold secrets we may never fully explore, but feeling their presence all the same. The idea of earlier civilizations also challenges our cultural narratives. Many societies hold beliefs that place humans at the heart of creation, whether through divine will or evolutionary triumph. The Silurian Hypothesis gently nudges these beliefs, asking what it means if others came before. Would it shake our sense of purpose, or enrich it? For some, it might spark wonder, a sense that the Earth has hosted many stories, each as vibrant as ours. For others, it might challenge deeply held truths, prompting a rethinking of faith or identity. This possibility, like a soft breeze, stirs the mind without demanding resolution. The lessons from such a discovery would be profound. If a civilization fell to environmental collapse, it might warn us to tread carefully, to protect the delicate balance of our world. If it vanished in a cosmic disaster, it might remind us of our vulnerability, urging us to prepare for the unexpected. If it thrived in harmony, it could inspire us to seek a similar path, to build a society that endures. The Silurian Hypothesis offers these lessons not as warnings, but as gentle invitations to reflect, to consider how our choices shape the story we leave behind. This reflection also connects to the broader universe. If civilizations rose and fell on Earth, could the same have happened on other planets? The search for extraterrestrial intelligence, tied to the Silurian Hypothesis, suggests that life and intelligence might be common, blooming and fading across the cosmos. Our own story, then, is just one of many, a single thread in a vast tapestry. This idea softens our sense of isolation, suggesting that we're part of a larger narrative, one that spans planets, stars, and eons. It's a thought that feels like a quiet hum, resonating through the night. The Silurian Hypothesis also asks us to consider the ethics of our search. If we found evidence of an ancient civilization, how would we treat it? Would we rush to dig it up, risking the loss of fragile clues? Or would we preserve it, letting future generations with better tools uncover its secrets? The hypothesis reminds us that the past is a shared heritage, not just for scientists, but for all of humanity. It's like finding a delicate manuscript, its pages brittle but precious, urging us to handle it with care. This idea also touches on our relationship with the Earth. If others lived here before us, they changed the land, the air, the seas, just as we do. Their impact might still linger in a faint chemical trace or a buried artifact. The Silurian Hypothesis asks us to see the Earth as a living archive, one that remembers every story, even those lost to time. It encourages us to treat our planet with respect, to recognize that our actions, like theirs, will echo through the ages. It's a reminder that we're temporary stewards of this world, tasked with preserving its history for those who come after. The philosophical implications extend to our sense of time. Human history feels long, but it's a mere blink in the Earth's 4.5 billion year story. If civilizations rose and fell millions of years ago, it suggests that time is vast, that our moment is fleeting. This perspective can be humbling, but also freeing, like realizing you're a single wave in an endless ocean. The Silurian Hypothesis invites us to embrace this vastness, to see our lives as part of a larger cycle, one that may have seen many intelligences before ours. The idea also reshapes how we view discovery. Science is often about finding answers, but the Silurian Hypothesis reminds us that questions can be just as powerful. We may never find proof of an ancient civilization, but the act of asking changes how we see ourselves. It's like gazing at a starry sky, knowing each light might hold a story, even if we can't hear it. This curiosity, this willingness to wonder, is what drives science forward, pushing us to explore the unknown with open hearts and patient minds. As we linger on these reflections, their gentle weight settling like moonlight on a quiet night, let's prepare to drift to the final chapter of our journey. The questions of our place in this story have unfolded, but now it's time to gather these thoughts and bid farewell, letting the beauty of the Earth's mysteries carry us to rest. Take a moment to breathe deeply, letting the calm of this journey settle over you. The universe's story is vast, and we're only beginning to uncover its wonders. Let's move gently forward into a closing reflection that wraps us in the peace of the unknown. As we drift gently from the reflective quiet of our place in the universe, where the Silurian Hypothesis asked us to ponder our fleeting role in a vast cosmic tale, we now arrive at the close of our journey, ready to gather the threads of wonder and let them guide us to rest. Welcome back to Sparx Science for Sleep, where we've wandered through the Earth's ancient layers, from rocks and fossils to the stars themselves, seeking signs of civilizations that might have come before us. Take a slow, deep breath, letting the calm of this moment settle like moonlight on a still lake. Tonight, we wrap ourselves in the beauty of these mysteries, reflecting on the journey and the science that lights our way as we prepare to say goodnight under a sky full of untold stories. The Silurian Hypothesis has been our guide, a soft melody of possibility, and now it's time to let its echoes carry us to sleep. Our journey began with the Earth as a grand, ancient book, its pages written in stone, holding secrets of civilizations that might have thrived millions of years ago. We imagined a world where intelligent beings, perhaps not so different from us, built lives and dreams, only to be buried by time. The Silurian Hypothesis, born from the curious minds of scientists like Adam Frank and Gavin Schmidt, invited us to question our place as the first to shape this planet. It's a thought that feels like a gentle wave, washing over us with wonder, reminding us that science is not just about answers, but about the questions that spark our imagination. As we explored, we found that the Earth's history is vast, its chapters stretching back billions of years, each one a story waiting to be read. In the layers of rock, we discovered the science of geology, where strata tell tales of ancient seas, volcanoes, and lands long gone. Scientists use tools like radiometric dating to measure the age of these layers, finding clues in the decay of elements like uranium or potassium. The Silurian Hypothesis asked if these rocks might hold more than natural history, perhaps a trace of a tool, a chemical anomaly, or a mineral that hints at a civilization's touch. It's like finding a single, unexpected word in a familiar text, urging us to look closer. The rocks, with their patient, enduring presence, reminded us that the Earth is a keeper of secrets, its story written in a language we're still learning to read. From there, we wandered to the fossils, those delicate imprints of life that paleontologists study with care. Bones, shells, and even tiny microbes, preserved in stone, tell us of creatures that roamed ancient worlds. But the Silurian Hypothesis whispered a bolder question. Could some fossils be more than biological remains? Perhaps a fragment with a geometric pattern, a trace of metal, or a structure that looks crafted rather than grown. These anomalies, rare and puzzling, are like stars in a daytime sky, faint but intriguing. Scientists use microscopes and chemical tests to explore these finds, seeking signs of intelligence in a record dominated by nature's hand. The chemistry of the Earth offered another chapter, where isotopes and molecules sing a subtle song of the past. Scientists analyze these chemical traces, looking for shifts in carbon, nitrogen, or oxygen that don't match natural patterns. A spike in heavy metals or an unusual compound might suggest a civilization's industry, like a faint echo of a factory long gone. The Silurian Hypothesis sees these clues as notes in a grand symphony, each one a possibility that challenges our understanding. Tools like mass spectrometry, with their precision, let us hear these notes, revealing a world where the Earth's atoms might carry the story of a forgotten society. We then explored the great upheavals of Earth-asteroid impacts, volcanic eruptions, and shifting plates that both erase and preserve the past. The Chicxulub crater, formed 66 million years ago, marked a moment when the dinosaurs vanished, its layers holding iridium and shocked quartz. The Silurian Hypothesis wonders if such layers could also hold traces of a civilization buried in the chaos of a cosmic collision. These disasters, like artists with bold strokes, reshape the planet, hiding clues in ash or mud, yet sometimes locking them away like treasures in a vault. Scientists study these moments, searching for anything that stands out, like a single thread in a woven tapestry. In the ocean's depths, we found a library of sediments and ice, where the Earth keeps its oldest records. Cores pulled from the seabed or polar glaciers reveal ancient climates, life, and events. A layer with an unusual metal or a bubble of air with a strange gas could hint at a civilization's work, washed into the sea or frozen in time. The Silurian Hypothesis sees these archives as pages in a book, each one holding a potential clue to a world we've yet to meet. Scientists dive and drill, using tools like sonar and spectroscopy to read these pages, seeking signs that might rewrite our history. The tools of modern science, from ground-penetrating radar to satellites, brought us closer to these secrets. LIDAR maps hidden landscapes, isotopic analysis finds chemical traces, and artificial intelligence sifts through data to spot patterns. The Silurian Hypothesis relies on these innovations, imagining that a buried structure or a faint signal could reveal a civilization's legacy. These tools are like lanterns, casting light into the Earth's darkest corners, showing us that the past is never truly gone, only waiting for the right moment to be found. Our gaze then turned to the stars, where the Silurian Hypothesis meets the search for extraterrestrial intelligence. Could alien visitors have left marks on Earth or nearby planets, in meteorites, on Mars, or in the icy plumes of Enceladus? The idea of a Dyson sphere or a cosmic signal stretches our imagination, suggesting that the universe itself might hold relics of ancient societies. Scientists use telescopes and probes to search for these signs, from unusual chemicals to patterns that defy nature's rules. The Silurian Hypothesis, tied to this cosmic quest, sees Earth as part of a larger story, one that connects us to the stars. Our reflections on humanity's place brought us to a deeper truth. We may not be the first to dream, to build, to wonder. The Silurian Hypothesis asks us to embrace humility, to see our civilization as a fleeting note in a vast melody. It reminds us that others might have faced the same challenges we do: climate shifts, resource limits, or the risks of progress. Their story, if it exists, is a lesson, urging us to tread lightly, to seek balance, and to cherish the Earth as a shared home. This idea, like a soft breeze, carries a sense of connection to those who might have come before, their lives woven into the same fabric as ours. Now, as we reach the end of our journey, we gather these threads of rocks, fossils, chemistry, disasters, oceans, tools, stars, and reflections into a single tapestry. The Silurian Hypothesis has been our guide, a question that opens doors to wonder without demanding answers. It reminds us that science is a journey, not a destination, a way to explore the unknown with curiosity and care. Whether or not we find traces of ancient civilizations, the act of asking changes us, making us more aware of our place in the universe's vast story. It's like standing on a quiet shore, watching the stars reflect on the water, knowing each ripple holds a piece of the past. The beauty of this journey lies in its openness, its invitation to dream. The Earth, with its billions of years, is a canvas painted with countless stories, some told, some silent. The Silurian Hypothesis asks us to listen to those silences, to hear the possibility of others who lived, loved, and left their mark. Scientists continue this search with patience and precision, using tools that see beyond the visible, hear beyond the audible. They remind us that the past is not lost, only hidden, waiting for the right question to bring it to light. This curiosity, this gentle pursuit of truth, is what makes science a gift, a way to connect with the world in all its mystery. As we close this chapter, we return to the stars, those distant lights that have watched over Earth through all its ages. Each one is a story, a possibility, a reminder that we are part of something larger. The Silurian Hypothesis, with its quiet questions, invites us to see ourselves as travelers in time, our lives a brief but beautiful moment in the Earth's long tale. Whether others came before us or not, their story, like ours, is woven into the planet's memory, carried in its rocks, its seas, its air. This connection, this sense of shared history, is a comfort, a reminder that we are never truly alone. The science we've explored tonight is a testament to human curiosity, to our desire to understand the world and our place in it. From the layers of stone to the signals of the stars, every discovery is a step toward knowing more, even if the full story remains out of reach. The Silurian Hypothesis is not about finding definitive proof, but about embracing the wonder of the unknown, the possibility that the Earth holds secrets we've yet to uncover. It's like a lullaby, sung by the planet itself, soothing us with its mysteries as we drift towards sleep. Before we say goodnight, let's pause to share a final thought. The The journey we've taken through the Earth's depths and the cosmos beyond is a reminder that science is a story we all share. If you've enjoyed this journey, consider leaving a comment to let us know where you're listening from and what time it is in your corner of the world. Perhaps you're in a quiet town, the night soft around you, or a bustling city, the stars hidden but still there. Your presence, your curiosity, is part of this story, and we're grateful you've joined us on this gentle exploration. The Silurian Hypothesis leaves us with a sense of awe, a feeling that the Earth and the universe are full of possibilities waiting to be explored. As you listen to these final words, let the questions linger, not as puzzles to solve, but as dreams to carry you into the night. The rocks, the fossils, the stars, they all whisper the same truth. We are part of a vast, beautiful story, one that stretches beyond our time, beyond our world. Let that truth be a comfort, a soft light guiding you to rest. And so, as the night deepens and the stars shine above, we come to the end of our tale. The Silurian Hypothesis has been our companion, a gentle question that opens the heart to wonder. Whether you're drifting off now or simply resting in the quiet, let the beauty of these ideas wrap around you like a warm blanket. The Earth's story is vast, its mysteries endless, but for tonight, you can rest, knowing you've been part of this journey. Sleep well, dear listener, and let the whispers of the past carry you into dreams, under a sky where every star holds a story yet to be told. Good night,